let's talk about hyperbola, and we're going to focus on identifying different parts of the hyperbola using a given table. First of all, let's do a quick refresher on what a hyperbola is. So it is a set of all points in a plane such that the difference of the distances from P to two fixed points is a constant, d. Okay, the focus, or the foci in this case, refer to fixed points, one of two fixed points that are used to define a hyperbola. So without going into a super complicated drawing, just imagine that you had some point P. Also imagine that you have 2 points, one I'll call F1, so that's one focus, and here's another one, F2. Okay, so I have a point and 2 foci. Now, let's say I want to know how far apart these are. I want to know the distance from P to F. So I'm going to call this distance A. So A just stands for the length of that green line. And this will be B. B will stand for the distance between P and F1. So these are the distances. When we refer to distances from P to two fixed points, F1 and F2, that's what I'm looking at. The distance A and the distance B from P to F1 and F2. Okay, so that's not so bad. Now, what's the other piece? They say set of points P in a plane such that the difference of the distances. So all that means, remember, difference means subtraction. So they just want to know how much further or closer is A to B or whatever. So difference of the distances, so A is one of my distances, B is the other, they want the difference. I'm going to wrap that in absolute value, meaning it doesn't matter if I do A minus B or B minus A, I'll get the same result, which is going to be D. So the set of all points in a plane such that this difference equals D are going to satisfy my rule and be part of my set of points that define my hyperbola. All right. So an equation of a hyperbola, a horizontal one looks like this, and vertical looks like this. Notice that it's basically the same, but the x and squared and y squared terms have been swapped. A horizontal hyperbola looks like this, and a vertical parabola or hyperbola looks like this. Okay? Notice that for a horizontal one, it almost looks like an H, so that's easy to remember, and a vertical one almost looks like a V. So that can help you remember how to identify by looking whether a hyperbola is vertical or horizontal. Also notice that these same three variables, A, B, and C, pop up frequently on this table. So it seems that if I know A, B, and C, I can define pretty much anything about this hyperbola, from asymptotes to the full equation. A refers to a coordinate, or one of the coordinates, of the vertice. So when you hear A, think vertex. B corresponds with the co-vertex, and C corresponds with the foci. Notice that I can't specify whether A is an x value or a y value of the vertices because it depends on whether I have a horizontal or vertical hyperbola. That means that if, for example, you told me that a hyperbola had a vertex at 7, 0, I would be able to say, well, it must be horizontal because according to this, horizontal hyperbola have zeros as y values in the vertice. Which brings me to my next point. This is, before we move on, this is just a photo representation of everything that's in the table. So these have the same exact information in them. If you're more visually inclined and prefer this picture to the table, take a screenshot of it and use that to help guide you instead, or to supplement it. Now, the point I was getting to is that if y equals 0 for vertices and foci, then we have a horizontal hyperbola. But if it's x that equals 0, we have a vertical one. Okay? So notice that here I have zeros in my y column, which gives me horizontal. Here I've got zeros in my x, which gives me a vertical. So that's one thing that's going to help us identify what kind of hyperbolas we're dealing with. Okay, let's do some practice. So we're going to be given a piece of information. We'll use the table to help us complete the question. So here we're told that a hyperbola has a vertex 5, 0 and a covertex 0, 3. So what can we figure out from that? And we're asked to write the equation in standard form for the hyperbola. Well, first we need to know whether it's a horizontal or vertical hyperbola. Well, because y equals 0 for the vertice, so here I have a vertice 5, 0, so notice I have a 0 as a y coordinate, and sure enough, 0 is here. So this must be a horizontal hyperbola. Now that I know that, I know that the basic equation will look something like this. Now I just need to fill in a squared and b squared. Well, it turns out that a squared corresponds to that a value for my vertice. So a equals 5. You can see that I looked at the x value of my vertex, looked at the table, and I'm matching that if a is here and a equals 5, then this a must equal 5 too. Same thing with my covertex. The y value is 3. If I look at covertices, the y value corresponds to b. So I'm able to fill in both a and b. So 5 is my vertex, b is my covertex. Now I've filled in everything I need, and I can take it one step further just by simplifying 5 squared and 3 squared. So this is the equation in standard form for this hyperbola. Let's practice again. So once again, we're asked to write an equation in standard form for a hyperbola. It's got a vertex at 8, 0 and a focus at 10, 0. So let's take a look. What does that mean? Is it horizontal or vertical? Okay, so my vertex has a 0 y value and my focus has a 0 y value. My vertex has a 0 y value and my focus has a 0 y value. So this must also be horizontal. Now, a little trickier this time because notice that once again they gave us a, because a is the x value of the vertex when we have horizontal hyperbolas. A is the x value of the vertex. So I know that a is going to be 8. But now I need to fill in b. How am I going to figure that out? I don't know the covertex. What I do know is the focus, which is 10. I do know the focus, which is 10. So how am I going to proceed from here? I'm going to use the Pythagorean theorem to solve for b. Okay? I'm going to use the Pythagorean theorem to solve for b. So, these, for hyperbola only, the vertex, covertex, and focus have this relationship. Meaning if I know 2 of the values, I can solve for the third one. I know the vertex, I know my focus value, I'm solving for b. So I just go through solve as normal, okay? Just reviewing this very briefly. So that means that b squared equals 36. So b squared is 36. So I'm able to fill that in for y and complete my equation. Okay, notice that I didn't even bother actually solving for b because I wanted b squared in my equation anyway. So again, I filled in a and b. I was able to get b using the Pythagorean theorem because a, b, and c, vertex, covertex, focus, do share this relationship for hyperbola, only hyperbola. All right. Let's practice again. Alright, so if I have a hyperbola centered at the origin that has a vertex 2, 0 and focus 3, 0, what are the coordinates of the covertices? So this time I'm not asked to find the equation, I'm asked to find covertices. I know the vertex and I know the focus. Remember, vertex goes with A, B is covertex, and C is focus. So once again, I'll use the Pythagorean theorem to solve for b because I know a and I know c, and I can use them to solve for b. So I set it up. My vertex, remember, is a, so I have a 2 for a. Focus becomes 3, which is my c value. Now I just solve for b. I get 4 plus b squared equals 9. B squared then equals 5, so b equals plus or minus the root of 5. Not always going to be pretty. Okay, So b equals plus or minus root 5. So now I want to know the coordinates of my co-vertices. So I see that co-vertices are equal to 0, b, and 0, negative b. So 0, b, and 0, negative b. I've got root 5 and negative root 5, and these are the coordinates for my co-vertices. I think this is my last practice I have set up. So we're going to write an equation in standard form for the hyperbola with vertex 0, 9 and co-vertex 7, 0. Same steps as before. First, always identify if we've got vertical or horizontal. Y is 0 for vertices and foci, then we have a horizontal hyperbola. If x is 0, then we have a vertical. Notice that this one is vertical because my vertex has a 0 x value. Just like over here, I see that for vertical, 0 is the x value. So this is vertical. So that means that I know that the setup of this equation is going to match this. Vertex, remember, goes with A. So I've already got A. Co-vertex, which they also gave me, goes with B. So I'm ready to fill in my equation. Okay, so 9 squared, which is my a squared value, and 7 squared, which is my b squared value. So the equation for this hyperbola is y squared over 81 minus x squared over 49 equals 1. So we've been doing a lot of practice with writing the equation in standard form, but notice that you could also be given an equation in standard form and be asked to identify vertices or foci or co-vertices. Just remember that relationship between our values for hyperbola, a squared plus b squared equals c squared. So if you're given 2, you can always solve for the missing one. With that, you should be able to take any piece, whether you're given equation, vertice, foci, co-vertice, or asymptote, and figure out any other piece of information. Just make sure to always make your first step figuring out whether you're dealing with horizontal or vertical hyperbola.